Welcome back, class. This is Mr. Neugebauer again. Go ahead and open your books to page 233. We are going to be doing lesson 3.7 today, solving system of equations by graphing. Basically, system of equation just means that there is more than one equation that we're going to be dealing with, or more than one graph. And actually today we're mostly going to be looking at graphs, but we're going to start off with an equation here. So what it says at a campground, basically it's offering tubing, kayaking, bicycle rentals as shown in this graph here. Right here it shows the deposits, okay? Over on the right then it shows the cost per hour. So the key thing to understand right away is that this deposit is not going to change. Whether you rent something for 1 hour or whether you rent it for 10 hours, the deposit is going to stay the same. The thing that's going to change, the cost part that's going to change based on how long you use it, is the cost per hour, okay? So whether I rent this tube here for 1 hour or whether I rent it for 5 hours, my deposit is staying the same, okay? Now when we look at y equals mx plus b equations, the b is the constant part. The b is the part that's not going to change. So when I'm looking at writing my y equals mx plus b equations here, the constant part, my deposits, are always going to be my b. So the first one wants us to write an equation for the tube, okay? So when I go ahead and write this, I'm going to write y equals, or if you want, you could put, c, cost equals. Now the m, my slope, that's going to be the thing that can change. It's going to be the thing that's going to be multiplied by my x amount, okay? So I look here at the tube. The part that's going to change, or that's going to depend and be multiplied with something else, is the $4.20. So my slope is 4.2 times x. X is going to be the number of hours, plus $15. Okay, so that's my equation for tubes. $4.20 an hour times the number of hours plus the guaranteed $15 deposit. Okay. Then number 2, it wants me to write one for the kayak. So I use the same idea, y equals mx plus b. I look for the kayak here. What part is guaranteed to not change? The $25 deposit. So y equals, and I'm going to put plus 25 out here for my b. Now what's the part that's going to be multiplied with something else? What's the cost per hour? $6.50 times the number of hours. So 6.5 times x. Then here, I'm going to write one for the bicycle. Well, same idea, y equals mx plus b. The m, the x are going to be multiplied, that's the hours, and then the rate plus my deposit. So y equals 750, 7.5, times x, which is the number of hours, plus the $20 deposit. Okay? So that's going to be my 3 equations I'm going to use to solve this table right here. It says find the cost to rent each item. 1, 2, 3, and 5 hours. So this math here, it's not too bad. I'm going to first do the cost of the tubes. Take my calculator here. I'm just going to do for 1 hour, 4.2 times 1, $4.20, plus the $15 deposit. So that's going to be $19.20. What about for 2 hours? Well, I take my 4.2 times 2. So it's going to be $8.40, but plus the $15 deposit. So that's going to be $23.40. Okay? And then I'm going to go ahead and move on to the kayak. I don't want to spend too much of your time here. On your own, complete this table, but I'm just going to do the first 2 for you. But when me and Miss Neely check notes, we're going to want this whole table filled out. Okay? So for the second one here, the kayak, it's 6.5 per hour times 1 hour, $6.50, plus the $25 deposit. So that's $31.50. Then what about for 2 hours? Well, for 2 hours, I do 6.5 times the 2. So the hour charge is only $13, but then I have the $25 deposit still, so I add 25. That's going to be $38 even. Okay? Then I'm going to have the bicycle, which is $7.50 an hour, so 7.5 times 1, $7.50, plus the $20 deposit. So we have $27.50. Now I'm going to do it for 2 hours, so I'm just going to do 7.5 times 2, and get $15 plus the $20 deposit. So for 2 hours, that's going to cost me $35. Okay. Now what me and Miss Neely want you to do, we want you to stop the video and finish the table. So go ahead and do that right now. Okay. Now that you have the whole table filled out, go ahead and turn the page. Now what we have over here is it says 2 or more equations with the same set of variables are called a system of equations. Okay. This is a system, meaning basically we're going to have 2 graphs at once, 2 equations at once. So right here, I'm just going to explain this real fast. It's wanting to know what is a solution, meaning what is an answer for both this equation and that equation. Okay? What is an answer for both? Well, an answer for both will be when the 2 lines meet. So basically all we need to do here is we need to graph one line, graph the other line, and then find out when they meet. So, and then we can check by plugging in this point for the x and the y, which is the x and the y for both equations. So I'm going to show you how to graph these, and I'm going to show you how to find the solution, and then I'm also going to show you how to check that. So here we go. Let's look at A right here. Well, let's look at this. These are both already in y equals mx plus b form, so this is going to be pretty simple to graph. So we look at this first one. There's nothing in front of x. So how many x's do we have? We have 1x. Well, the slope then is 1 over 1. So look at my b, my start point is -1. So I'm going to start on this one, down 1. Then from there I go up 1, over 1. And a straight edge, like a ruler or something, will probably help you out. Then I'm going to make a straight edge here for that one. So this is the top one. Then for the second one, it says -2 is my b. So I'm starting here down 2. Then from there, my slope is up 1, and then I have to make it a fraction over 1. So I go, up 2 over 1. So I go up 1, I go up 2, and I go over 1. So I go through this point again, and I'm going to use a straight edge and make that line. So the solution is where these 2 lines meet, which is right here. Now what is that point? Well, I went forward 1, up and down nothing. So that point is the point 1, 0. Okay? And that is my solution. But I have to check that. How do we check that? Well, that's the x, that's the y. I take my first equation, y equals x minus 1, and I plug in 1 for x, and then I plug in 0 for y, and I solve. 1 minus 1 is 0. So does 0 equal 0? Yes, if you get a true statement, you know your answer is right. But now I have to check the other one because it has to work for both. So I have y equals 2x minus 2. Now I plug in 0 for y. I plug in 1 for x. So 2 times 2 is, or 2 times 1 is 2. So I'm left with 2 minus 2 here, which still equals 0. So I get a true statement here, a true statement here, so I know my answer is correct. So once again, to solve a system of equations, all you have to do is graph the 2 lines, see where they meet, write down that point as your answer, but then you have to check your answer by plugging in the x number, the first one for the x, plug in the second one for the y. Okay? Go ahead and do B on your own, do the picture, make your points clear like I did, circle where they meet, plug it in, and then also remember to check. Alright guys, let's continue with example 2 here. Right here, basically it says Gregory's motorcycle, has motorcycles, 2 wheels, and ATVs, 4 wheels. The store has a total of 45 vehicles that together have 130 wheels. So basically what we have here is we have 2 different types of things. We have an ATV with 4 wheels, a motorcycle with 2 wheels. So we can actually use 2 variables for those as modeled in the problem right here. We have y and then x. Y representing 2 wheels, motorcycles, the 4 represent, or the x here representing the ATVs with 4 wheels. And what we know is that all of that together will have 130 total wheels in the shop. So what we're looking for is basically to make essentially 2 different graphs here. We have the x plus y equals 45 for the 45 vehicles. Then we have the 2y plus 4x equals 130 to represent the 130 wheels. So we have two different equations here. We have x and y, the two vehicles, equaling 45 total vehicles. Then we have a separate equation of the y's still being the motorcycles, but now we're talking in terms not in vehicles, but we're talking in terms of wheels. There's 2 wheels for the motorcycle, 4 wheels for that. So once again, the goal is again to see where these two lines meet. Well, what we notice first here is that x plus y equals 45 is not in y equals mx plus b form. It's not in slope-intercept form. So we need to get it there so we can graph. So what we did here, I'll show you the work because you're going to have to be able to do this work on your own, so pay close attention, is basically we want to get it to look like y equals mx plus b. Now, the problem here is that this is on the wrong side. So we want to get the x over there, so we subtract x over to get to the opposite side. You do the opposite. That leaves us with y equals negative x plus 45, and a negative x is a negative 1x, so negative 1 over 1. So that means for this one, our y-intercept is going to be at 45 right here, and then we're going basically down 1 over 1. Notice each of these boxes are 5 here and 5 here. So basically we're looking at going down 5 over 5, down 5 over 5, and so on, because down 5 over 5 is the same as down 1 over 1, all the way along. Then our next equation, 2y plus 4x equals 30. Once again, that is not in y equals mx plus b form, so we have to write it down and figure out what in the heck do we need to move. So here we have 2 y's, here we have 4 x's, so I need to move my 4x over. That'll leave me with 2y equals negative 4x plus 130. Now my problem here is that it is 2y. How do I get y by itself? I divide by 2. So that whole thing gets divided by 2. So I have y equals, well here we have negative 4 being divided by 2, which gives us negative 2x. Then we also have to take the 130 and divide by 2, which gives us 65. So positive 65 right there. So our y-intercept, if we extend the graph up, is going to be at 65, and then it's going down 2 over 1. And if you graph that one, which has already been graphed for you, just using this as an example, they meet right here at that point. So that's an x forward 20, and then a y up 25. Then to check, we take 20 and 25, plug it into this equation, x for 20, 25 for y, and if you get a true statement, like we do here, then if we plug them in, once again, for y 25, for x 20, plug those in and get a true statement, we know our answer is correct. Now we're going to work through C on our own down here, okay? So it says Creative Crafts gives scrapbooking lessons for $15 per hour plus a $10 supply charge, okay? So we want to get a y equals mx plus b equation, again, slope-intercept form. Now, the slope is the thing that can change. That's kind of what we talked about earlier. What's the constant thing, like with the kayaks and all in the tube at the start? What's the constant thing? What's the thing that's going to change? The constant thing that's always going to be the same as the b, and then the part that's going to change is our m. So if we look here, it's $15 per hour and a $10 supply charge. So the constant thing is the $10 supply charge. That's going to be there, okay? But then they're charging you per hour. So it's going to be the 15 times hours, which would be like 15 times x. So if we look at this, we now have a y equals mx plus b equation. Y equals 15x plus 10. That's going to be our first one. Then we look at the next one. It says Scrapbook Incorporated gives lessons for $20 per hour with no additional charge. So here there's no startup fee, so there's no B. There's no supply charge. There's no guaranteed money. All they're charging is the $20 per hour, 20x. So if there's no B out here, we know our B is 0. So let's go ahead and graph these and figure out where they meet. So here, I'm going to graph the bottom one here first. I'm starting at 0. My B is 0. That's my y-intercept. Then 20x is really 20 over 1. So that means I go up 20 and over 1. up 20 over 1. Now I'm going to use a straight edge, make a quick line. Okay. Now, let's look at our next one. Y equals 15x plus 10. My b, my y-intercept, is going to be 10. And then I'm going up 15 over 1. That's 15 over 1. So I'm up 10, 15 over 1. We haven't met yet. I'm up the rest of the 5 to 30, up 15 over 1. And notice they meet right here. But I'm going to go up 15 over 1 again, just to make a good line. Connect those. And we see that they meet at this point right there. Well, what's that point? X is 2, y is 40. So they meet at the point 240. So basically what that means is at 2 hours, they will each be equal at $40 total spent. All right? So that's how we check that. Now, let's move on to the next page. These I'm going to talk about, not so much do. This is just kind of information you need. Pay very, very close attention. Okay? All this is showing is if you have two lines here, look at your y equals mx plus b's. What do you notice about the slopes? The two of these equations have the exact same slope. They're both 2 or 2 over 1. What's different then about these equations is that they have a different b, a different y-intercept. So if these are two different things, like two different craft shows, just like the last one, they're going in this direction, okay? The graph is going up like that. These lines are parallel because they have the same slope. You may want to please write that. Actually, I'm going to tell you, write that out to the side. Right here, me and Miss Neal are going to check your notes. We want to see you write down that if lines are parallel, they will never meet, okay? That's basically the definition of parallel. If they're parallel, they will never meet. Which also means, then underneath that, write, that means no solution. Once again, solutions are when the lines meet, okay? That gives us a good solution. However, if lines are parallel, meaning they have the same slope, but different y-intercepts, different b's, these are never going to meet. So we are never going to have a solution for these because they never meet. So, write that down there. That's basically all this is telling you. You can read it more if you want to. Now look down at example 5. What we actually have here is one line here, then a second line. Let's see, where's our second line? Oh, right here. And if we turn both those into y equals mx plus b form, these lines end up right on top of each other. So here we have a slope of 2. Here we have a slope of 2. So we have the same slope, and we're actually going to end up with the same y-intercept. So these lines are smack on top of each other. So what we don't want you to write here, and we're going to be checking your notes for this, right? If lines are on top of each other, there is a infinite, right here, number of solutions, okay? So right here, right, if lines are on top of each other, there's an infinite number of solutions, okay? So once again, parallel here, no solutions at all. Here, infinite number because they're on top of each other. Every single point is a solution. Okay, let's look over here at an example. These two we need to graph. This top one here is already in y equals mx plus b form, so it's going to be pretty nice to graph. Okay, the one over here is not. So we need to change 3y equals 2x plus 15 into y equals mx plus b form. Well, what thing's in the wrong spot? Well, really nothing. The only thing is y is a times 3 here. We want to get rid of multiplying by 3 by dividing by 3. So we get y equals, well, 2 divided by 3 just turns into 2 over 3x. So our rise of 2, run of 3. Then 15 divided by 3 is 5. So we have our first equation, 2/3 x plus 3. So we start at, there's 2, there's 4, in the middle is 3. You got to be very careful when you graph these. So our y-intercept's 3, then we go up 2, so 1, 2 over 3. Once again, this is a 2, so pay attention. 2, and then right in the middle here is 3. Then again, we're going to go up 2, 1, 2 over 1, 2, 3. There's that line. Then we're going to graph this one. We start at 5, a y-intercept of 5. So here's 5. Now what do you notice right away? We have the same slope, up 2 over 3. Up 2 over 3. They have the same slope, different y-intercepts. So, no solution. They're parallel. They'll never run into each other. Then here, if you use this one, we have 2 that we need to convert into y equals mx plus b form. We have y minus x equals 1. We need to move the x over, so we add x to both sides, so y equals x plus 1. Nothing's in front of x, so there's 1x there, so it's 1 over 1x. So here we start at 1, and then go up 1, over 1, up 1, over 1. That's that line. Now we need to do this one. So we write it down, y equals x minus 2 plus 3. Well, this one's simple. All you have to do is combine your like terms. What's a negative 2 plus 3? 1. Once again, nothing's in front of x, meaning it's 1 over 1, 1x. Same y-intercept, plus 1, same slope. So these lines are on top of each other, so you'd put infinite number of solutions. Finally, example 6. Once again, I'm going to do more talking here than actual work with this one. All this is saying is basically using 2 points, you need to find their slope. So here we have a set, here we have a set. Use your y2 minus y1 over x2 minus x1, find your slope. So this point has a slope of negative 1. This point has a slope of 2 if you plug those in. Okay, so you know your m's. Now here's where you need to be smart. They actually give you the b in the problem, but you got to think about it. And this is going to be on your assignment as well. Notice this point, you are forward 0 and up 5. Your x is 0, your y is 5. That means your y-intercept right here is 5. Because you're forward nothing and up 5, that's a y-intercept on that line. Then your slope is down 1 over 1, down 1 over 1. So that equation is y equals negative 1 over 1 x plus 5. So kind of look for the zeros here. Here x is 0. So my y-intercept is negative 1, so I have minus 1 out to the side. I have my x. What's my slope? 2, which is 2 over 1. So I start at negative 1, then I go up 2 over 1, up 2 over 1. They meet right there for the solution. Okay? So we're going to do this one very quickly, and then you'll be done. So I have 2 points here and here. For both of them, I need to do the y2 minus y1 over x2 minus x1. So here, my y2 is 4 minus 2 over 1 minus 0. Now think, which one's my y-intercept? Well, here my x is 0, so the y that goes with it, my y-intercept's 2. So 4 minus 2 is 2. 1 minus 0 is 1. So my slope for the first one is 2 over 1. So my equation is going to be y equals, my slope, 2 over 1, x, what's my y-intercept? 2 plus 2. There's my first equation. Now we do the second one. So my y2 is 1 minus my y1, which is negative 1, over my x2, which is 1, minus my x1, which is 0. Minus and negative really means plus. So 1 plus 2, 2, over 1 minus 0, 1. So here my slope is also 2 over 1. Well, what's my y-intercept? Well, here x is 0, so negative 1 minus 1 is my y-intercept. These two lines have different y-intercepts but the same slope, so you know they're parallel, so there's no solution. Okay? If you had questions at all, rewatch whatever you had questions on, and come to class tomorrow ready.